There we go. Hello, everyone. I'm Ashley. I'm use they, them pronouns. I'm with NAGT. And today we have hands-on with PolarPASS teaching. Oh, excuse me. This is not the right slide. There we go. That was a sneak peek preview for our next webinar, but this webinar is hands-on with PolarPASS, easy tools to bring GIS skills and Polar curriculum to your classroom with Alia and Twyla. For anyone who's unfamiliar with NAGT and the NAGT webinar series, the webinar series is a one-stop shop for increasing our community's capacity in Earth education. These webinars feature novel and innovative work such as Earth education research and pedagogy, new teaching materials, and the classroom and professional experiences of people just like you. The NAGT webinar series is free and open to the public. We often get questions about whether it's okay to invite your colleagues. Yes, please do. The chat box is a place for discussion, questions, and comments. Please put any of your thoughts in there. Don't just feel that you can only limit it to specific questions. Additionally, you can use the reactions tab to share like cute little emojis for reactions. Otherwise, in terms of interacting with each other, please remember that we follow the NAGT Code of Conduct. I'll go ahead and drop that link in the chat for you in case you need to review it. And that's everything from me, so I'll go ahead and turn it over to Alia and Twyla.
Thanks, Ashley. Great. And
shall I share screen here?
Sounds good, Twyla.
Great. All right, how's that?
Yes, thank you. We have it. Awesome. Yeah, so I'm Alia, and Twyla Moon is the lead PI on this project, and we're excited to talk to you today about using PolarPASS curriculum that we've been developing for the last several years in your classroom, and easy tools to bring GIS skills and Polar curriculum into your classroom. And our co-PIs are also Anna Gould, Spruce Schuneman, and then other affiliated researchers are Emily Ward and Daniela Pennycook. Next slide, please. All right, so today this is our kind of overarching agenda. We'll give you an overview of the PolarPASS curriculum and give you some time to explore the website as well, which is hosted through CERC. Then we'll take a look at QGIS and QGreenland and some of the specific GIS activities that have been developed within PolarPASS. We'll have some time for questions and answers. Then we'll share some tips from educator experiences and talk about potential ways to implement these activities in your classes. And then again, we'll have some more time where you can explore QGIS and QGreenland, and we'll be here to support you getting that set up. So in the chat, if you could please share your name, institution, and the audience that you teach. So are you teaching at the undergraduate level, community college, PUIs, primarily, undergraduate institutions or R1 universities as well? It'd be great to see the diversity of faculty that we have here today. I think we can move to the next slide, or I guess we could take a minute and see. Thanks for populating in, and I guess I can say I'm an associate professor in the Department of Environmental Sciences at Western Washington University. It's a primarily undergraduate institution in Northwestern Washington State. And so I've been teaching this in two of my classes, Watershed Biogeochemistry and Global Change in the Cryosphere. Twyla, do you want to introduce yourself too?
Yeah, sure. I'm Twyla Moon. I did put it into the chat too. I work at the National Snow and Ice Data Center, which is part of the University of Colorado Boulder. And I don't teach formal university classes. I teach workshops, summer schools, many of those sorts of things. So this has been a really fun collaboration in which I've gotten to bring a lot of cryosphere knowledge and learn from others teaching.
Great, thanks. Yeah, so our objectives today are, and I want to point out this is a two-part series. So in 2 weeks, I think it is, our colleagues Spruce and Emily will be presenting on another part of the PolarPASS curriculum. So today we're talking about the GIS activities, and they'll be talking about some of the 360 interactive education activities, and Twyla will talk a little bit more about those as well. But so today we'll learn about the PolarPASS curriculum. All of the learning activities have been designed with active learning strategies in mind for undergraduate audiences, and the goal is to bring more information about glacial hydrology, albedo, and mass balance changes in Greenland into undergraduate classrooms. Then we also hope that you'll become more familiar with PolarPASS activities developed in QGIS, specifically QGreenland, which is and QGIS is an open source GIS software. And so we'll also be using the free QGreenland data package. And then we'll talk about tips from instructor experiences in undergraduate classrooms and have time to answer questions about implementation and setup. And thanks, Ashley. It looks like the second PolarPASS webinar will be November 17th.
Yeah, thanks so much. So to give you a little idea too of the PolarPASS curriculum and concept overview, it really sprung out of a note that polar data was needed in the classroom, that we have really rapid changes happening at our poles, both of them warming more rapidly than the global average, and the Arctic at 3+ times that rate. But a lot of undergraduates, polar places still feel really far away, disconnected to their day-to-day lives. So we wanted to take some work and think about how to produce some curriculum that could help to bring these places more alive for students. So PolarPASS is NSF funded. It's Polar Space and Place, which is what became PolarPASS. And it's 2 modules. The first one, exploring the glacier basin system, and the second one, long-term spatial transformations of the glacier basin system, each with 4 or 5 units. We designed the curriculum for upper level undergraduates, so probably more like geoscience majors, but actually the curriculum has already been tested in classrooms that don't quite fit that description. So we've tested this in with 5 different instructors, and some of them, like Alia, teaching more than once. And it's been in a range from classrooms where they're focused on GIS skills to other classrooms that are focused on Earth system or geology. So we are doing now a lot of integration of these teaching tips from folks who have worked on this. And the 2 modules together are roughly a full semester course or a full quarter course if you teach 3 quarters in your standard year. And we'll send you to this website in a minute to take a look around. So the units combine polar field data. So there's both in situ measurements, satellite imagery, multiple kind of data forms, and then 360 interactive environments. So that's what the November webinar focuses on, is learning more about teaching with 360 interactive environments, and then also GIS data and GIS environments that we'll talk about today and focus on today. So the idea is that with all of these things together, students are really feeling more immersed in polar places and ready to think about seasonal changes, short to long-term variations in the connected Earth system. So since we're not going to focus on the 360 IE today, we just wanted to give you a little preview. So this is a snapshot from one of those. You can kind of get a sense here of what those environments look like as students can tour from one location to the next, look all around, bring up videos of locations, bring up information images that tell them more about what they might be seeing in these different locations. We have also like some comparative video. So one of the 360 IE students are looking at what the glacial runoff it looks like at different times of year and thinking about what hydrology from a glacier basin system looks like versus hydrology from a non-glaciated basin or something along those lines. The activities are about using authentic data. So that's what we'll dig into some today with seeing the QGIS environment. For any of you who have used ArcGIS, QGIS is going to feel familiar but slightly different. But just to say that really all of the things that can be done in ArcGIS can be done in QGIS and vice versa. And so it's a really nice tool for helping students to know software that they might be able to use throughout their careers, separate from necessarily needing to fund having proprietary licenses like with ArcGIS. So we have satellite data, kind of focus areas that we look at, and students are then also gaining these GIS skills along the way. So we thought next we would go ahead and give you some time to dig in. Let me, stop my screen share. We'll give you a little bit of time to dig in to the PolarPASS website and just kind of take a familiarizing look around yourself. So here's, I'll put into the chat the website link for the curriculum and encourage you just to take the next few minutes to look around there and open files, poke, check things out, and be familiar. And feel free to put in any questions in the chat or bring them up. And we'll spend the next couple minutes doing this. Share my screen to do this. All right, so I think for many, then a nice place that for starting when you're starting with PolarPASS curriculum is partly making sure that you have all of the tools that you need. And here, the QGreenland website, so just QGreenland.org, has a get started page that can make sure that if you have maybe students might be doing this on their own computers or laptops, or maybe you have an assistant at your university who's going to set up a computer lab to be ready for your classroom. And so in any of these cases, this is an easy place to start with downloading your QGIS. So there and QGIS, the nice thing about it too, unlike ArcGIS, is it's available for any platform, Mac, Windows, Linux. You're going to download your QGreenland core package here. It's a kind of a big download. It's about 3.5 gigabytes. So that is something that takes a little bit of time to do. You're going to open up that file, that download, and this is what it's going to look like. Is you're going to have a QGreenland folder, and then within that is a whole set of folders, and these named folders are going to match the layers that we see in QGIS when we open it up, and they're going to contain the data that we're then visualizing. So you can see I can follow these all the way down to the data files that are used, which also means that once you have all these data files, you can use them in any QGIS project you want. There's a README, a quick start guide, also the complete user guide. So there's lots to get to know here. And then if you are continue on this get started page, one thing you might consider is we have about a 1-hour video tutorial series that can really take you from zero to hero on using QGIS and being familiar with what's in QGreenland. And then there's lots more as far as documentation, troubleshooting, GitHub discussion space, things like that. So we want to make it really easy for you to get started, but then lots of resources for you to continue. So that is getting set up from the QGreenland page. And once that's ready, your students have it ready, it's on your computer lab at the university, you can either open up QGIS and then open up QGreenland, or I can just go to this QGIS.qgz file, double click that, and it's going to open up on my other screen. So give me a minute to scoot it over here. Okay, so it's gone ahead and opened up QGIS for me. And you can see I've arrived at a blank screen, which is a little disconcerting. This happens depending on the way that you open it. And I can just go over to any of these. So you can see this is kind of that same file structure that you have in the folder that you opened. And I could just right click and zoom to this layer. This is often the view that QGreenland is going to open up in. Again, it's just going to depend on some nuances of how you open the file. So I wouldn't worry about that too much. And now, once you're in here, you can kind of think of it as like this exploratory data layers for looking around. There are some layers here that require an internet connection because they're really high resolution. So, for example, we have a 10-meter satellite image mosaic. So I might go ahead and use that one to zoom in here on some areas of interest. And I could get even, very, very close in so that I can have some high resolution satellite imagery. And these kinds of internet required layers can take a moment to load. So you can explore this kind of space with your students. I could also kind of go back to these bigger views and maybe check out populated places that exist around the island. And you can see, gosh, it's kind of hard for me to see those. So again, I might zoom into an area to check out. And suddenly I can see lots of these towns and villages. And I might even check out like the buildings that exist in one of these places. So you can see the town and village there. And there are going to be lots and lots of different kinds of data layers. So I might zoom back out here. Think about checking out, for example, there's some location where ice cores have been drilled around the ice sheet. I might look at what our mass balance, whether we're gaining or losing ice in these places over these different periods of time. And all of these are going to have ways you can find out more. So I can just hover my mouse here, and it's going to tell me a little bit about this data set. It's going to tell me that it's a derived trend. It's going to tell me about the resolution, but often I might want to find out more. So I could right click on one of these and open this bottom properties. And that's going to open up something that looks like this. There's lots of things you can do in here. QGIS, like ArcGIS, is something you can continue to use kind of high level, or you can really dig in. So it's powerful that way if you want to use it for deeper information. You might want to change the symbology of the layer you're looking at. Or I think often the other most useful thing in here is this metadata, because this is going to tell you more about the data set. It's going to tell you about where it came from, how you might cite the data, where you might go if you want to get more information on that data, or maybe continue to get more data. And there's a lot of flexibility in how you use this space. So for example, maybe I was wanting to pile up some of these different layers on top of each other. And I wanted to see, where are there mineral and hydrocarbon licenses, and I want to think about them, on top of something else. I could just go ahead and move this layer wherever I want it to exist. So I could move it here so that it's regional climate model data would appear on top of it. So this order from top to bottom of the layers over here is giving you the order that you're going to see them in your map view over here. So that's something that can be kind of a common first bit of confusion, is I've turned things on or off, but I don't see them over here. Or for example, maybe you've deselected your layer up here and suddenly everything under it disappears, right? So this is kind of a stacked hierarchy. And yes, the, layers can also be made less opaque. So for example, I have this layer that I'm seeing right now. I could open up those properties. I could go to the symbology and I could work in here for introducing some transparency, or I could just go with a different type of symbology too. So there's a lot of flexibility in this, and this is where the internet is your friend for finding ways to do things. And I would say QGIS has multiple ways you're going to be able to do any one thing. So that's another thing that's useful for keeping in mind as students are exploring this space. They might find really different ways to do different things. So that's kind of a introduction into just what it's going to be like as you're opening up QGIS and opening up QGreenland. So I'm going to then pass it over to Alia to help us look at the, kind of the first GIS activity that arises in the PolarPASS curriculum.
Thanks, Twyla. I'm always amazed at how much there is, just the potential for QGreenland. There's so much in there for research too. It's great. All right, so I'm gonna bring us over to, I'm gonna start with showing you the website. So hopefully everyone's had a chance to look at that a bit. Are you seeing my screen? Great.
Yeah, looks great.
All right, awesome. Okay, so this is module 1. And you'll see over here on the right, there are 5 units within module 1. And there are, one note, I guess, about the curriculum pages is that there are teaching pages that are just for the instructor, and then a separate set of pages that are for the students as well. So for example, this is the student materials page, which is something that you can share directly with the students. And then you can have access to the instructor page that you don't share with the students that also has answers to the exercises and things like that. But so today we're going to explore within Unit 2, which is about glacier mass balance, albedo, and surface melt. If we scroll down to Unit 2, Part 2, here is an exercise. Part 2 exercise uses the QGreenland and QGIS environment. We have our setup instructions again here, and then the instructor exercise. So feel free to download that. And then I'm going to go ahead and open up that document as well. Okay, so here you can see there's a really nice, nicely documented exercise.
Can you zoom in on that one a little bit more on
Sure.
that?
Sure. Let me. I'm gonna go further.
Yeah, great, thanks.
Okay, yeah. All right. So there's a unit summary. I always like to give the students a little bit of time to read the summary, and then we talk about it together. And you know, what processes are occurring at the glacier surface and how do these influence albedo? So this ties into the Unit 2 overarching idea or learning objectives. And so, so then you can see we step through how to add additional data layers. So as Twyla showed you, there are a number of layers already in QGIS. And then for some of these exercises, we bring in additional data layers that are then downloaded, and students add them to their QGIS packages themselves. All right, so I might just talk through a little bit of, I guess in the next step, we'll talk about implementation and things like that. I think you could approach it in different ways with either stepping through each step together or, kind of starting everyone off and then having students work on their own time and asking questions as needed. But I just want to show you a little bit here. You can see we'll add in these data layers of sample points, various satellite imagery, some monthly albedo maps, and surface albedo from MODIS. Here, again, pretty detailed instructions for the students to step through as they add each layer and open those up in the QGIS package, or in QGreenland, excuse me. And then some screenshots as well to help them navigate and visualize what it should look like on their screens. All right, so I'm just gonna show you all what this kind of looks like here. You can see there are also some zones of interest. So then we have questions for students to then look at how these different zones compare to each other. I think I'll bring us back over to QGreenland. Let me. And so now you can see what this looks like once the students have added in some of these layers. So here we're starting with that initial screen. Then we can toggle on and off some of the different layers here, and we can zoom to this group, to this region, and turn on and off some of our different layers of interest here. Okay, I'll just start from the beginning. So we have our surface elevation change points, then some of the satellite imagery, the Landsat images, and some MODIS surface albedo. And so then the students are asked to step through and answer various questions based on the visualization and identifying properties based on the different layers and different zones of interest. Let's see, find the, somehow, yeah, here are the different zones. Yeah, I don't know, Twyla, do you want to add anything here in terms of?
Yeah, I think one of the things that we really try to do with the exercises too is we use, some of the data in QGreenland, but we didn't, we wanted to allow, lots of data that students aren't using is available if you want to have extra times for students to explore or, think about other data that might be connected to their interests along those lines. But we also, as Alia showed, that exercise activity has students adding data to this space. There are other parts of the exercise where they're using those surface elevation sample points to extract data from other data layers within here. So there's a lot of really cool GIS tools and skills that students are learning. So I think even for students whose main interests might not be the polar pieces, or that might be harder for them to see in their future careers. These GIS skills are really widely applicable. And I think at those of you who brought up, bringing this with your high school research students or your undergraduate researchers, I think is really nice kind of intro activities, even for helping them understand how they might use GIS in other times of their work too.
Definitely, and this is the instructor version of the exercise. You can see we've included some example plots of what the students should be producing to help with grading and things like that. But the student one would not have these. So these are kind of what the student should then produce. So they export the data and then create an Excel figure, or it could be a figure with another program, but to then visualize the data that they're extracting from QGreenland. Are there any questions while we're here?
And we're happy to take questions that related to the specific curriculum or QGIS or QGreenland.
And at the end of the exercises, we always have some synthesis and reflection questions too, to have the students think about how this exercise relates to the learning objectives of the unit as well.
And there are examples also of student responses too. So we have assessments that then are kind of matched with what those responses should look like too. So the one of the great benefits of having this tested in different classrooms outside of our development team too is we've gotten a collection of teaching tips, and that's some of the modifications that you'll see happening on the PolarPASS website over the next coming months, as we'll be continuing to add in more of these teaching tips that have come from people teaching different in classrooms. We've had it taught in everything from a block to a semester with a seminar class or a lecture and lab class, or like I said, also different emphasis topics. So we'll be sure to continue to provide more of those tips for folks. Katie's wondering about how big the unit is, more of a weekly lab, or how many lab sessions you would take. And actually, if you want to, Alia, to kind of then dive into the teaching tips, and we can have a little more question time at the end.
Yeah, that sounds great. Maybe I can just share it since I'm already here. Whoops.
No problem.
Okay. Yeah, so that's a great question, Katie. So we have, maybe I'll go through these slides real quick and then answer your question more specifically. And Robert just asked, how often is the data updated? I'm not sure, Robert, if you're asking about the data probably in the data layers for QGreenland. Yeah, so for QGreenland, QGreenland's roughly updated once per year. And some of those data layers are then updated to that year, or some of them aren't, depending on what the collected data contains. Sometimes they were like limited field campaigns or something along those lines. The next phase of QGreenland development is entirely focused on making it easier and easier for folks to find and add just the data they want. So that might continue to evolve, but these kind of QGreenland version 3, the sort of thing that I was just walking around now, will continue to be something that's available too. Yeah, so yeah, as Twyla mentioned, we have tested. Oh, I think you got to flip our view. We're seeing a black screen. Oh, okay, thanks. Let me start that. Yeah, over. No worries. Okay, interesting. Maybe Twyla, do you want to share your screen with the slides for some reason? Yeah, no problem. Some issues with. Let me just pop that one up. Okay, great. Thanks. All right, so as Twyla mentioned, we have tested the curriculum in a variety of different types of classrooms. So definitely face-to-face classes, QGreenland, the PolarPASS exercises, specifically the QGreenland ones, are really nice, obviously, for computer labs. I think Katie was asking, let me bring up your question again. about how big each unit is. So the 5 units, for example, of module 1, I think teaching that, so I teach on a quarter-based system, so they're 10 weeks, and I was teaching a 3-credit lecture, 2-credit lab class. The lab would meet for about 4 hours a week, and the lectures are 3 hours a week total. And I think teaching all of module 1 took me about a month actually of the classroom time. So I'd say each unit is maybe about a week, roughly. The units themselves vary a little bit in length, but one way that I think, so far we've been teaching everything together. I think there's a lot of flexibility in kind of picking and choosing which units are most appropriate for your class or how that might fit into your syllabus. But I'd say they're roughly about a week, and then the entire unit, but you could also choose specific exercises. For example, the QGreenland exercises, and I'd say each one of those is probably roughly 4 hours worth of student time. And so some other ways you could do it is, if you don't have a specific lab time, but you do want to bring this into the classroom, you could have students get started and then they could finish it as homework. And you could also, assign them into groups so that they could work together. Spruce teaches on the block schedule. And so I know for him, he can have a full day to devote to some of these activities, which I think can also be really nice if you have that sort of schedule. When we started this, it was during the pandemic. And so I taught the curriculum twice online. And I actually found that to go pretty smoothly because the instructions for downloading are so nicely laid out that the students didn't have much trouble getting it started on their own machines. And then what I did was also I had it set up on campus at a computer lab so students could choose to either go to campus and work through it in a lab there together, or they could do it on their own machines at home. And then we would share screens and stuff like that. Yeah, so I think online is also, if you teach hybrid or online, there are definitely ways to utilize it as well. All right. So just some tips that I think myself and Spruce and others have found is that if you happen to have a TA, it can be really useful to have them run through the module ahead of time and be ready to help answer student questions during the lab. I think if you don't have a TA, you could also find an eager student or a student that has taken the class before and ask them to help out in that way. I think it can be nice to have a couple people circulating, depending on how big your class is, to be able to help answer some of the questions that arise.
Yeah, I was going to mention too, one of the classrooms that someone outside of our group tested this was, he was teaching a GIS class. And so as he formed groups, he often made sure that there was a geology or earth science student within each group to help be able to kind of bring this geoscience curriculum to an audience that might not have that expertise.
That's a great point. And everyone can approach this differently. So either you'll have access to the links that are publicly available for the curriculum. So you can either point students directly to those pages, or the way I've done it is I just copy and paste what's there into our learning platform, which is Canvas, and then the links stay embedded. And then you can also create more specific exercises, chunks that work for the timing of your classroom. So I might assign, an exercise and a half or a unit and a half, or however you can kind of break it up as you want, and then create a deliverable within Canvas or Blackboard or things like that, and ask students to upload however you want them to. Sometimes I'll have them upload a screenshot. Say to get started, I'll say, download QGreenland in QGIS, and then just upload a screenshot to show that you're ready to get started next week. And, things like that, where you can then copy the instructions, put it into your learning platform, and kind of simplify things that way. And then I think it's important to remind students that learning to navigate QGIS is part of the learning experience. So, especially depending on how much background students have with GIS and how much background the instructor has too, that part of the learning experience is also to become more familiar with this amazing open source software tool as well.
And then I think we'll take a little bit of, before we share just our very last slide, we'll take a little time to address also lingering questions. And there's also one more question there in the Slido. So again, that's this link. About any of your concerns about teaching with GIS, and if there are maybe just 5 minutes that we can take to chat about folks' questions or concerns. One thing that I found is so I'm the lead creator for QGreenland. And so we're always finding new uses and spaces for it to be used. And one thing that I find common for folks new to GIS is actually just the nervousness about getting started. So that's why, partly why we tried to create some really simple get started and create the video series for folks to follow along, because there are things that are useful concepts when you're using geospatial data. For example, I'll just show you here. For example, there are different data types that might appear differently. So for example, over here, you can see that this ice slab thickness in this data set, which is around the edges here, you can see that those are point data. And that's different than, for example, this data set. You can see it's got this little square symbol next to it, which suggests that it's raster data. So it's kind of data in a specific location versus data that covers your whole map. So there are some kind of, I think, fun and useful concepts like this that also get covered in that introductory video series, which is the one that is highlighted here. Are there other concerns that folks or questions about the curriculum using it? Yeah, solving the mechanics of GIS and not as much an analysis. I think that is where Alia's point of, in part, remembering that using the tool is part of the learning. And you might even sometimes have instances where you're trying to sort out doing something, and you might ask different student groups and maybe compare, especially if they come up with different ways of doing things. I think that's actually a helpful way to learn more about the GIS while realizing that there's more than one way to do something.
It looks like, yeah, some other very valid concerns about prep time and testing connectivity. I could see that's really interesting that you have some elderly students, whoever put that in, but I could see this being sort of interesting for people who may be retired and might have time to explore. And so, yeah, I think, as I mentioned, one thing I do is like a week ahead of time, just give the instructions and ask them to download and upload a screenshot showing that they have successfully downloaded and opened QGIS and QGreenland, just so that that comes ahead of whenever you're going to actually start, and kind of eases the anxiety of getting started on the day of the lab.
Also, I would note that, so I showed you some of those internet required layers, but only those layers require the internet. So once you've downloaded QGIS and once you've downloaded QGreenland, you can actually use all of those different data sets and that software without an internet connection. And none of the data that's included in any of the activities are any of the internet required layers. So it is okay to run all of the curriculum and exercises and also explore probably 90–95% of what's in QGreenland without an internet connection too.
Katie, thanks for, I'm not sure if it was Kate, but whoever, thank you for clarifying that it was the laptops that are elderly, not the students. I was thinking that would be an interesting population to work with. Okay.
There is the possibility, I'm going to mention this, I feel like this is a little bit next level, but for those of you who like computing, you might be interested to know that there is actually QGreenland available in the cloud. And I will go ahead and work to find the link for an article. I'll put it in here that describes using QGreenland in the cloud, which is available via something called CryoCloud. So that's just a fun little side note, but maybe, you know, jump to level 301 if you're into something like cloud computing.
Well, is the CryoCloud housed at NSIUC?
The CryoCloud is actually, it's a NASA funded project, and it's led at the Colorado School of Mines. So I just put the link in for that CryoCloud, and that could be a route for folks who want students to be able to access more data analysis space and find QGreenland and QGIS, sans QGreenland in the cloud.
Great.
Well, I think we're in our last few minutes here, and Alia and I will, of course, stay on too if there are questions, or if anyone has downloaded QGIS or downloaded QGreenland and you want to open it up and get started. We're happy to answer those questions and help make sure that you can do that. And I know Ashley also has a few items for wrapping up our last couple of minutes of the webinar too.
There we go. I do. Okay. Let me get a few things adjusted and I'll go ahead and share all of those things with you all.
And I'll just mention, we would love to hear, you know, we hope that you'll use this, and we'd love to hear about how it goes. And if you have questions and things like that, feel free to reach out to myself and Twyla.
Yeah, maybe do you mind, Ashley, if I put up our one last slide here, make sure that that information is available to folks. So just a little reminder on the PolarPASS website, getting started with QGIS, QGreenland, and of course, contacting us. And Alia's point, we're happy to kind of further share teaching tips, help you conceive of how to teach things, get over bumps, discover new ideas, or connect you with others who have taught the curriculum already too.
Yeah, and I think definitely think about it as being modular as well. So feel free to grab parts that work for your syllabus and your class, And yeah, we'd love to hear about how it goes. Thank you.
Thanks, Ashley.
Awesome. I'll go ahead and share my last PowerPoint slide. There we go. So, oops, that didn't work. Sorry, it's the first webinar of the season. So I'm experiencing just a little bit of technical bumps here and there. I'll thank you, Alia and Twyla, for that wonderful presentation today. We did record this session, and the recording will be made available on the webinar website, but please be patient for a few days while it's processed. We like to caption the videos just to make sure that they are more accessible. And after this webinar, please take a minute to complete the end of webinar survey. I'll send a link in the chat in a bit to provide us with feedback. And this is also how you will be able to get to the certificate of attendance. Also, keep an eye out, or maybe an email out for information about our next NIG2 webinar, which is another PolarPASS webinar entitled Hands-On with PolarPASS, Teaching with 360-Degree Interactive Environments. And that'll be on November 17th. We'd love to see you all there. Thank you again to everyone for attending today. And an extra thank you to our presenters. Thank you, Alia and Twyla, excuse me. Have a great Thursday, everyone.